Hello and welcome to this video in Angle from Derant. What I would like to talk about today is how Angle works with data and how Angle can detect compromise in your network. For this purpose, I've uploaded some test data into Angle that contains a compromise of the network. So without further ado, let's get into it. We're logged into Angle now and are on the dashboard. So here there's a lot of general information about what's going on with the system. We should notice now that there's an alarm that has come from the data that I uploaded into Angle. And let's just go ahead and check out this alarm. So here it is. This row is describing the alarm. There's a little bit of information about it. We can see that it is a network Trojan that Angle has detected. We can see when it's raised, and we can see the data timestamp of the data. There's a little bit more information when you actually click on the row. So here, for example, you can see the IP addresses that was communicated between and a few of the ports. So let's actually just go over to the data analysis tool and inspect some of the data. Here we have the data analysis page. The first thing we need to do is actually select some data to look at. So the sensor we select, and we start looking at the catalog. This is where the alarm was raised. And finally, we have to select the date where the data is actually located. And for this test set, it's the 29th of March. So here we actually have quite a bit of data. This data is Suricata actually alerting on some traffic that is seen before and that it suspects could be a compromise. So right now we have 5,584 rows, which is by far too much to manually look through. So what we can actually do, and the goal is to filter out some of the connections and some of the alerts that we don't want to look at. It could be false positives, it could be like policy violations that we are fine with in our company or things like this. So let's go ahead and look at the filters, and let's go ahead and check what kind of filters we have in here. We actually have a filter for the Topsy, and we have some Microsoft filter, and these filters should take away a lot of the rows that we don't want to look at and leave us with an interesting data set. All right, so just 4 rows left, and these are definitely some interesting ones to look at when we consider that we actually want to find the compromise going on and the compromise that has been already alerted on. First up, let's look at some of the information that Angle is actually presenting us with here. We have a timestamp for when the communication is going on. We have IP addresses and ports, and some extra information about what Suricata sees is going on here. For this row, the communication is coming from the source IP and is being sent over port 80, and it is being received by the destination IP, so 10.10.10.13, and over this port. The extra information that I mentioned just before is, for example, the alert signature, where Suricata is trying to give a brief description of what it thinks is going on. And also it has categorized these descriptions a little bit. The alert severity is Suricata trying to give an estimate of how severe this alarm is or this alert is. And the leftovers are usually a lot of different things, and you can find some interesting information about the connection there sometimes. We also have the application protocol being communicated on, and you can see that it actually fits together with the source port HTTP. So let's look a little bit at what is actually going on in this communication. The first row is a executable file or a DLL being sent from this server to our server in the network. And the next one is Suricata detecting some communication to a known command and control server. So this is now our server in the network who is communicating with this IP address, who the Fjordo tracker is saying is a command and control server. The next thing Suricata sees is the Cobol Strike tool. It is detecting some communication that looks like it's coming in relation to the Cobol Strike tool, and it is again on 10.10.10.13 server. And finally, it is seeing that some USB metadata is being submitted, and this is from our server and then to somewhere on the internet. The last one of these rows seem to be legit traffic. We are sending some metadata to a Microsoft server. So all in all, we see here in the Suricata logs that the first three are clearly indicating that a compromise has happened of this server. And to look a little bit further into it, let's check out some of the HTTP traffic actually going on also. Here is 9 rows that we can look into. We don't have any filters to sort out data here, but 9 rows are okay to look at. Let's check out the IP addresses, and the first thing I notice is this one. This is the same IP address that we just saw in the Suricata log. And what is going on here is 2 requests, one GET, one POST request. Immediately the POST request is interesting, coming from our server and then going to this server that we initially downloaded the exe file from. Now what is happening here is that we're actually sending them a file, and it is a file called final result fiscal year 2021 to 2022, and it's an Excel file. So we've been compromised, or the network has been compromised, and data has been exfiltrated from one of our servers. Now that we have done a little bit of initial investigation into what has actually been going on in our network, we can go ahead and change the status of the alarm so that we don't have the red mark, the red notification up here. So let's go back into the alarm view, and we find the alarm, we edit it, and we set the status to being handled. We've not yet actually done any work to solve the compromise and make sure it doesn't happen again, but we have done an initial investigation, and the alarm is now being handled, and we can continue with the incident response process.